This is section 1.1, Building Blocks of Geometry. In this section, we will introduce and define many of the basic building blocks of geometry. The most basic elements of geometry are points, lines, and planes. We can find representations of points, lines, and planes all over the world. For example, a map of Pennsylvania, scattered with dots to represent the individual cities. Electrical lines are representations of lines. And a basketball court is a good representation of a plane. Let's define point, line, and plane. A point is the most basic building block of geometry. It has no size. It has only location. It's represented with a dot and named with a capital letter. A line is a straight, continuous arrangement of infinitely many points. It has infinite length in both directions, but no thickness. Name with any 2 points that are on the line. A plane is like a flat surface that has length and width, but no thickness. It extends infinitely long in its length and width. A plane is named with a script capital letter. Because each of these elements of geometry has a unique characteristic, for example, a point has no size, a line has no thickness, and a plane also has no thickness, some mathematicians argue that you cannot define a point, a line, and a plane. And certainly, the elements that we talked about previously, the examples in our real world, are simple representations of points, lines, and planes, but not actually points, lines, or planes. Taking a look back at these representations, of course the cities in Pennsylvania have a size. Of course the electrical lines don't go on forever. And of course the basketball court also has boundaries. So the definitions we see here are more explanations of what these things are represented as and how we name them. Let's take a look at a few more vocabulary terms. Collinear, objects that are on the same line. Coplanar, objects that are on the same plane. A line segment, 2 points, known as endpoints, and all of the points between them that are collinear to those 2 points. And finally, a ray is a point, known as an endpoint, on a line, and all of the collinear points on one side of the endpoint. Now, it's important that you pay close attention to these vocabulary terms, and if you need to pause the video now to write these down, then do so. As you will see throughout the school year, geometry is a language. The vocabulary makes up that language, and it is extremely important to be able to talk the talk before we can walk the walk. Throughout the course, we'll talk about how important it is to choose your words carefully when defining terms or even explaining processes. Pay close attention to how these terms are defined and commit them to memory. Next, we're going to talk about some notation. Notation and symbols are also very important in geometry. On this slide, we have 3 different figures. First, we have a line segment, AB. Then we have a ray, EF. And finally, we have a line, CD. We can identify each of these things because of the notation or the symbolization at the ends of these. We see the line segment has 2 endpoints. We see the ray has 1 endpoint and then continues infinitely in one direction. And finally, line CD is represented with 2 arrows on each end to show infinite length in both directions. Now, how do we write what these things are geometrically? Well, to write line segment AB, we would use the 2 endpoints and put a line segment over the top. Some people choose to put endpoints on their line segment. This is not mandatory, because as long as that line segment does not have arrows on the end, we know it stops. Next, the ray. We have ray EF. So we use the endpoint and a point on the ray, along with the ray symbol above it. Now, an important note about naming a ray: you must always start with the letter that is the endpoint of the ray. Looking back at the line segment, we named that line segment AB. We actually could also name this line segment BA. When naming a line segment, the order of the letters or points doesn't matter, but when naming a ray, it does. Finally, we look at line CD. Line CD could also be called line DC. The order of the letters does not matter. We simply choose 2 letters that are on the line, and then we put the line symbol with the arrows on each end above to indicate that it's a line and not a line segment. This paragraph is taken right out of our textbook, and it describes something that's very important. It says you can write line segment AB using a segment symbol as line segment AB or line segment BA. There are 2 ways to write the length of a segment. You can write AB equals 2 inches, meaning the distance from A to B is 2 inches. You can also use an M for measure in front of the segment name and write the distance as the measure of segment AB equals 2 inches. If no measurement units are used for the length of a segment, it is understood that the choice of units is not important or is based on the length of the smallest square in the grid. So, after reading this paragraph, it's important to take away the 2 different ways to identify and name the measure of a segment. First is line segment AB equals 2 inches. That tells us the distance from A to B is 2 inches. The second way is using the M for measurement. The measurement of line segment AB equals 2 inches tells us that's how long the segment is. Looking at the examples below, on the left in figure A, we have line segment AB, and it is being labeled with a 2 for 2 inches. Looking below that, we can see the 2 different ways to name it. We have AB equals 2 inches, or the measure of segment AB equals 2 inches. Looking at figure B, the second example, we have a graph with a grid, and we have segment MN that has a length of 5. Now in this case, let's say that the units are not indicated. So we can say that MN equals 5 units, meaning the distance from M to N is 5 units, or we can say the measure of segment MN equals 5 units. Here are a few more definitions. Congruent: figures that have the same shape and same size. For segments, 2 segments that have equal measures or length. Midpoint of a segment is the point on the segment that is the same distance from both endpoints, And then finally, bisect, to divide the segment into 2 congruent segments. Next, we're going to talk about the notation for equal and congruent. You use is equal to with numbers, and you use is congruent to with figures. So let's look at the two figures that we have here. First, we have triangle ACD over here. And we can see that side AC and side DC are both 3.2 centimeters. So they are equal in length. If we want to say that their measures are equal, then we would write AC equals DC. However, looking at the second example, if we want to say that the segments are congruent, then we would say segment AC is congruent to segment DC. Also here, we are being introduced to the symbol for congruent. It may be a little hard for you to see, but right here is the symbol for congruent, and it is an equal sign with a squiggly line on top. Okay, so how do we identify that segments are equal and congruent when they're shown to us like this? Well, obviously here, line segment AB and line segment CD are congruent, or at least it appears to be. But how would we want to make sure that somebody knew they were congruent or had equal length? We do this by simply putting a tick mark on each segment. Since each segment has one tick mark on it, that shows anybody looking at it that they are congruent. We can also see that segment EF and GH appear to be congruent and equal in length. How would we represent that to somebody that was looking at it? We would put 2 tick marks on each. So looking at this slide as a whole, we can see that A, B, and C, D are congruent because they each have 1 tick mark. E, F, and G, H are congruent because they each have 2 tick marks. But of course, A, B is not congruent to E, F, or G, H.